Okay. Let me see. All right. So no major announcements. It's just I have that as what the end of week 10. So week 12, we can anticipate exam 3 over chapter 2, covering sections 2.1, 2.2, and 2.3. And so today we were just going to get through as many homework questions from section 2.2 as we can. With my 3 o'clock, we were actually able to get through all 20 of these questions in like 30 minutes, right? We were able to do it. So I'll try something similar here. Let me just check Zoom one more time. I don't think there's anybody in the waiting room. So I'll try to get through these quickly. Just stop me if anything is not clear, if you have questions about anything. And otherwise, let's try to get through this. So consider this polynomial, write the degree, right? So the degree of this polynomial is the highest power on any variable. So in this case, it's going to be 5. Okay. The leading term is a term with the highest variable. So in this case, it's going to be 2x to the power of 5. Leading coefficient is 2 from the leading term. The constant term is a term with no variable. That's just going to be -6. Okay. All right, so the degree is going to be the highest power on any variable. In this case, that's going to be the 3. Now, the leading term, you might be tempted to say 5x cubed, but we need to account for that 8 in the denominator. So because we're dividing by one term, i.e. we're dividing by a monomial, we can distribute that into the numerator. So in reality, the leading term is 5 over 8 times x to the power of 3. Okay. So then that means the leading coefficient is 5 over 8. Okay, that was it there. The degree is the highest power. In this case, it's going to be 4. The leading term is the term with the highest power. So that's going to be pi over 2 x to the power of 4. Okay. And the leading coefficient is just pi over 2. Okay. So when we were discussing like some of the properties of polynomial functions, we said that their graphs are smooth, continuous curves. So that means that there are no sharp corners or edges and no holes, gaps, or breaks. So because of that absolute value term, that's going to create a sharp edge in our graph. So it's not a polynomial function because of the presence of the absolute value. Okay, if we were to rewrite this by distributing that denominator into the numerator, the first term would turn into a 1, and then we would have plus 7x to the -2. The powers on our variables have to be non-negative integer exponents. So -2 is negative. So because that power is negative, it's not a polynomial. I'll check attendance again at the 15-minute mark for people that's coming late. This one's not a polynomial because of that cube root x to the 5th. All right, that's the same as x to the power of 5/3. So the powers have to be non-negative integer exponents. This one's not a polynomial function because basically you have an asymptote on the y-axis. So you have a hole or a gap or a break. So because of that, it's not a polynomial. This one, again, we have a hole or a gap or a break because it's not continuous, so that's B. Okay. So the y-intercept. If we're going to find the y-intercept, we set x to 0. And so if we plug in 0, the output here is going to be 0. So if we use the leading term test, the leading term in this case is -x to the power of 8. So the -1 as a leading coefficient means that our graph is going to fall to the right. And with the degree of the polynomial being 8, which is even, that means the other side does the exact same. So it falls to the right and falls to the left. The only one that falls to the right and the left is B. So that was the application of the leading term test. Same thing here. The leading term in this case is x to the 4. The leading coefficient is positive. That means it goes up to the right, so it has to be either A or B. And then the degree of the polynomial is even, so the other side is the same, so it could still be A or B. And our y-intercept is 6, so that means that it's A. All right, okay. Okay, the y-intercept, so for the y-intercept, we said x is 0, the output is going to be 8. Okay. If we use a leading term test, it should go up to the right and down to the left. I think there's only one graph that goes up to the right and down to the left, which is this guy. So the access to write the zeros of this, we're fortunate because it's already in factored form, so you can just look at it and get the zeros. So the zeros end up being 7 and -2. So the multiplicity of 7 is the power on that binomial factor. The power there is an implied 1, so the multiplicity is a 1. But the multiplicity on -2 is 2 because the power is 2. So when x is 7, because the multiplicity is odd, that means it's going to cross the x-axis. And because the multiplicity of -2 is even, then it's going to bounce off the x-axis. Okay. The zeros, again, we're fortunate because it's already factored. So you can actually just look at it and get the zeros. In this case, it's going to be 2 and -5. Okay. So the multiplicity of 2 is 3 because the exponent is 3. The multiplicity of -5 is 2 because the multiplicity is 2. I mean, the power, the exponent is 2. So when we're looking at the 2, that had an odd multiplicity, so that means it's going to cross the x-axis. And when we're looking at the -5, it had an even multiplicity, so it's going to bounce off the x-axis. All right, minimum number of turning points. So the maximum number of turning points is going to be n minus 1, where n is the degree of a polynomial, right? So if we were to expand this polynomial all the way out, we would have an x cubed term times an x squared term, which would give us an x to the 5th term, right? So the highest power is going to be x to the power of 5. So that means the maximum number of turning points is going to be 4. Okay. The zeros here, okay. So we need to use the quadratic formula. Like the first 0 is simple, x to the power of 4 equals 0. That one's going to be 0. But the second one, we should probably use a quadratic formula. I'm gonna just kind of type it here. So quadratic formula, -b, so that's gonna be 3 plus or minus. Here, let's do, we need a fraction, so it's gonna be 3. I'm just gonna put plus for right now. The square root of b squared, which is 9, minus 4 times our a, which is 1, and c is -1. So that's going to become a positive 4. Okay. Over 2a, so that's going to be divided by 2. That's going to be 13. Okay. And then this is going to be 0. And we need another one. Of course. Shyster. Can I undo? No? Okay, that's fine. -b, so it's going to be here. Let's do, we basically need like this. That's fine. So we need like this. this. Let me do this. Let's get rid of that. Get rid of that. Okay, let's try this again. So that's going to be 3 minus square root 9, 4 times 8 times c. I think it was 13, right? Over 2. I think that was it. 3. So that's going to be 9 minus 4 times 8 times c. So 9 plus 4 is 13 over 2a. So 3. Okay, then we got to do 3 plus square root of 13 over 2. Okay. So those radicals came from the quadratic. The 0 came from the x to the power of 4. Okay. So the furthest left is going to be one of the zeros from the quadratic formula. That occurred once, has a so that means it has a multiplicity of 1. The middle 0 is going to be the origin. It has a multiplicity of 4. And the rightmost 0 occurred once, has a multiplicity of 1. Okay. So the leftmost 0, because it has an odd multiplicity, is going to cross the x-axis. The middle 0, because it has an even multiplicity, is going to bounce. And that last one is going to cross. Again, if any of this is not clear, you just have to catch my attention and we can like change the rhythm. Let me see. We still got a solid 2 minutes before. Okay, I'll go ahead and do this one. This one, I mean, this one's a little bit involved. So we're actually using intermediate value theorem to show that this polynomial has a 0 between 2 and 3. So when we did this on Monday, we showed that, if one endpoint is positive and the other endpoint is negative, because polynomial functions are smooth continuous curves, in order for the polynomial to go from positive to negative or vice versa, it somewhere has to cross the x-axis between these x values. So there has to be a 0 between 2 and 3 somewhere. So an extension of how we're going to evaluate that today is the following. We're going to do a table of values, right? So if I go to my y equals and put in this polynomial, let me see. I have 2x hat 4 minus, is that like m? Minus, okay, that's okay. Let's just, okay, 2x to the power 4 minus 4x to the power 3, 4x hat 3. Okay, minus 14. Okay. So then I want to look at my table. So our claim is that the 0, now there's a quick way to do this. Let me go ahead and do the quick way since I want to check Zoom. I'm going to go to graph. And again, there should be a 0 between 2 and 3, and you can see it there. So then to find a quick way to find a 0, if I'm on an 83 plus, I'm going to hit second calculate and number 2 for 0. So, and it'll approximate the 0 for you. First, I'm going to find a left bound. So I'm just looking for the cursor. Okay. So first I'm going to choose something left of my 0, okay? Then I'm going to choose something to the right of my 0. And then I want to choose something close to my 0, right? I'm going to get as close as I can. That's about as close as I can get. Okay? So according to this, we have 2.466, right? That second 6 tells us to round up. So we should do, if we want 2 decimal places, it's going to be 2.47. Okay. All right, so that was a quick way. I think this next one is similar, and I'll show you another way, the way that the text does it. Let me just check Zoom really quickly. Okay, let me get this to it. Okay. So we just saw one way to do the intermediate value theorem. Let's see another way to do it. So this is a repeat just with different numbers, okay? So if I put in this polynomial, I have x hat 5 minus x squared, which is I, minus 13, okay? All right. And our zero should be between 1 and 2. So first I want my table to start at 1 and change by 0.1. Okay. So we're going to look at a table of values. And like basically we're going to look at when x is 1, when x is 1.1, 1.2, 1.3, 1.4, until we get to 2, right? So it should be 10 outputs. So if I go to my table and we want to see, okay, we want to see when we can see a sign change, right? So there's a sign change between 1.7 and 1.8, okay? So now what we're going to do, now we're going to have the table start at 1.7 and we're going to zoom in. And so now we want to look at, we wanted to change by 0.01, all right? So I'm going to go to table set. We wanted to start at 1.7, but now we wanted to change by 0.01, okay? Now if we go back to the table, and now we're looking for our sign change. The next sign change is between 1.74 and 1.75. So because they want us to round to 2 decimal places, we need to zoom in again, do it one more time. So we're going to have the table start at 1.74, okay? And we wanted to change by 0.001, okay? Let's go to the table. Right here. So we get a sign change between 1.741 and 1.742, right? So if we round to 2 decimal places, these both round to the same 2 decimal places. So they both round to 1.74, right? So we're going to do 1.74. Okay. Let me check Zoom really quickly. Okay. Right here. Let's go on to the next question. We're almost done. Let me see. Yeah, I think we got like about 5 or 6 more questions left. So, you know, this is all live stream, so you can always go back and watch it again. For this function, okay, the in-graph behavior, right? So we're using the leading term test. The leading coefficient is a +1, which means we should go up to the right, but the degree of the polynomial is odd, which is 7, which is odd. So the other side does the opposite. So that means that we should fall to the left and rise to the right. It should fall to the left and rise to the right is B. Okay. So we said falls to the left and rise to the right. It looks like only one of these graphs does that, which is C. I'm just going to go with C because it falls to the left and rises to the right. Okay. Okay, here, right? If we're doing the leading term test, you might be tempted to say, oh, the leading term is -7x squared, but it's not. You got to expand it, right? You need to distribute and expand it all the way out. So this one, the leading term is actually -7x to the power of 3. So because the leading coefficient is negative, it falls to the right, but the degree of the polynomial is odd. That means the other side does the opposite. So it should rise to the left and falls to the right, which is B. Right. Okay, so sketching this graph. Like when I did it this morning, it kind of gave us a little bit of hard time, but I was successfully able to graph these. Let's just kind of walk through it. I kind of want to zoom in some. Because I still need to see that yellow. I think that shows everything better. Okay. All right. So to graph this guy. So now, it's a degree 3 polynomial, right? So it's going to take on this S-shaped curve. So I'm clicking there. Now the way it's presented to us is already in factor form. So that gives us our zeros off the rip. So we know here, and what I had to do earlier was I just clicked, we need 4 points. So I'm just clicking 1, 2, 3, 4. I just clicked at 4 random spots. And so what I'm gonna do is just drag these to the right position. That just seemed like it was a lot easier. So when X is 0, right? Okay, so the first 0 is the origin from that X squared term. So that means that the origin is one of our zeros. Another 0 is gonna be X equals -1. So I'm gonna drag this to -1, which is there, okay? It probably is a good idea to try a -1/2. Let me see. But I'm gonna hold off on that for right now. Let's see. We know it bounces there. So now I'm going to try maybe when x is a +1. So when x is 1, you get -7 times 2, which is -14. So when x is 1, we should be at -14. All right, okay. So we got that one. See, so once you have a clean point, then you can, again, I needed that little thing in the upper right-hand corner. Now, I thought I made it so that you can type these in, but that doesn't seem to be an option. It's just a matter of finding clean points. And then, again, what I did was I clicked 4 random points and then dragged the 4 points to a proper point. We got one more we need to find. Okay. No more zeros. Okay, so let's try when x is -2, right? So if x is -2, that's -1, that's 4. So that's a -4. -4 times -7 is +28. That goes off the chart, right? Let's try when x is a -1.5 or -3/2. So let me see. -1.5. So that's a -1/2, 3/2. So then that's 9/4, 2/4, over here. 9/4 times a -1/2, and I think this is getting nasty too, is a -9/8, and that doesn't get clean, all right? 9/8 times 7 is positive. Let's see, what else could we try? We just need that final point. I think we tried the -1/2. I think we did 1 already. We did 0. Did we try? I think we tried the -1.5. Let's try -1/2. I think before we did -1.5, let's just try -0.5. Let's see if we get something there. So if we do -0.5, okay, we get what, a +0.5 there. We get, so that's a half times a quarter is 1/8. It's still not see, we need to be able to type that. Like if we can type our number, that would help us. I might just need to do a different one. This is the same trouble I ran into with the first one. -1/2, that's a +1/2, that's a +1/4, that's a +1/8. So it finishes with a -7/8. So that point that we need to graph is -1/2, -7/8, but we can't. Let me see. -1/2. Yeah, we can't get there. Let me see. It's just because that point is off. And that's the same trouble. Let me see. Let me just block for now. Because it should have been an option to type our point. I might just do another one that has a cleaner point. That's what ended up happening before. Because it's off because of this guy here. Let me see. Yeah. It's that final point that we just can't seem to get. Okay. Let me put it let me just put it close for now. Something like that. Click a point, select. So and it went away. I'm just gonna get this one wrong and I'm just gonna try another one. Because I guess sometimes they have clean points and sometimes they don't. So I'm just gonna click in 3 and 4 random spots, hit save. It's gonna be wrong, but I'm gonna redo it because we just can't, like, we need to be able to type it in there. Like I said, I thought I had that as an option, but it doesn't seem to be. You can see it there, and we were a little bit off, but that's okay. Let's just do a similar one. Okay, let's try it again. So it falls to the right and rises to the left. Okay, so it should be A. Hopefully this one gives us a cleaner choice. Okay, let's try graphing this one. So we need to be able to see that, and that is fine. Okay, it's this tool, and now what helped me in the past, I just clicked 1, 2, 3, I just clicked 4 random points. So now, when X is 0, or one of our zeros is the origin, so I'm gonna drag this point to the origin, okay? One of the zeros is when X is -2. Okay, so I'm gonna drag this to -2. Okay. Okay. So it should bounce off the origin and it should fall to the right. So let's do when X is 1, right? When X is 1, we get 3. That goes off the chart, doesn't it? Okay, let's try when X is -1. So that's a 1, so that's 7. When X is -1, Y is 7. Okay. And the origin is where it needs to bounce. What are we missing? Falls to the right, rises to the left. The origin is where it needs to bounce. That should cross there. Let me see, when X is 0, yeah, it collapses to 0. When X is 1, it's a positive 21. Maybe when X is a half. But we said that the leading coefficient is negative, so it should go down to the right and up to the left. -2 is your 0. What am I missing here? It should cross at -2. Let's see. Because it's behaving a little bit weird. It should cross there. It should bounce there. It should go down to the right, but it's not bouncing there. I'm trying to think. Down to the right, up to the left. When X is -1, and that one seemed like it worked, right? That's a 1. That's a 1. -7. Oh, I put +7. That's why I was like, why is this not working? We plotted that point incorrectly. It's supposed to be -1, -7. Right there. Okay, there we go. Okay, so now we can get it to bounce. So then I think we tried when X was 1 that went off the chart. Let's try a half. So for the half, let me just use the calculator. Okay. So if I go to my Y equals, I got this, I guess I can type it here. Negative, where's the negative? Is that this guy? -7x squared. Okay. I don't know what my parentheses is. That's 8. Okay, parentheses x plus 2, close parentheses. Okay. All right, so that's what we're starting with. Now we want to calculate this when x is a positive 1/2. So I'm going to go to variables. We said a positive 1/2. That's not clean. What about when x is 1? I see 20. The trouble is, can we scroll? Maybe we can scroll. The trouble is because it's giving us points that are going off the chart. Let's try a quarter, I guess. No, because we can't do that one. And it definitely needs to be, let's try a -1/2. Let's see if that's any easier. But I don't think that'll help us. It needs to be something to the right of 0. And we need to be able to type in our result is the trouble. And I think X1 goes off. Let's try 0.75. That's even worse. That's within range, but it's not clean. That sucks. It's not fair. Okay, let me see. When X is 1, we got negative 21. And then when we did a positive 1/2, we got negative 4.3. So that's about as close as we can get. So like this last one, we really need to be able to type it in. What do we get? 4.375. Delete it or move it with this. Can we just type it in? No, you're not gonna let me type it. Let's see. Let's see. But yeah, so for this reason, hang on, make it bigger. Maybe if we zoom in. Coordinates of the object, drawing tools, plotting, where is it? Click to enlarge, save, graphing tools. Okay. Let's see if I can zoom. If I could zoom in, that would work. What is this point? That should be the origin. Yeah, that's weird because there was an option to type it in where there should be. 4.2. '21 goes off the chart. Can we scroll? It's not gonna let me scroll. All right. Yeah, that one we just can't get because of the settings. So, but because of stuff like that, that's why I removed the interactive figures from the exam. So, like, if this would have popped on an exam, I wouldn't force you to do it because we're not going to get credit for it because we can't get to the exact point. You see? Now, what's this point? They got, yeah, they did the half. Let's see, we can't get to that. I'm gonna just do one more. It's taking longer than I wanted, but okay. Down to the right, rises to the left. Okay, see? And then let's try. It's my last attempt. If I can't get it, then I'll give it up. All right. So this tool, I'm gonna just click 1, 2, 3, 4. So one of the zeros is the origin. Another 0 is -2. This looks like it's a repeat. Okay, nope. Right there, okay. So when X is -1, we're at -7. So another point is -1, -7. Right there. And then I think we kind of have the same kind of issue. And I think it's the 7 that's kind of mucking it up. Like if X is a half, let me see, is that the same one? I kind of wanted something different. It's -7x squared, x plus 2. Let me just do a similar one until we get that to change. Because the whole point was that was supposed to be different. Let me hit save and check. It's the right form, but again, it's just because we can't get to that final point. I'm gonna just try one more. But again, the whole point was that we were supposed to get a different question. Similar question. 3. Let's try it. I think everything else is the same. Let me think for a second. Let's just try it and see what happens. It should fall to the right and rise to the left. Here it is. This one. Check. Okay. So now we go to graph right here. Okay, this one. I'm just going to choose 4 points. 1, 2, 3, 4. That's fine. Okay. So one of the zeros is the origin, okay? Another one is x equals -2 is another zero, okay? When x is -1, you get -3, right here, okay? And let's try when x is 1. When x is 1, -3 times 3 is -9. All right, so that one's on the chart. So yeah, I think with this one, you just had to try it. And if you find yourself getting like a number where you can't plot it, just cycle it until you get another question that you can plot, right? Because that's the 7 was throwing that one off because we couldn't plot, we couldn't change the zoom. They wouldn't allow us to type anything. So I kind of cycled through until I got one where I could plot the full 4 points. And that's just the nature of that one. More than likely, it won't show up on the exam like this. And also, what I've been doing is that on the exam, if it's like an interactive figure, like how this one was, I just been discarding those questions because it's more technical and it's less about the concept or the application of what we're talking about. I only got 3 more questions, so that one kind of ate up our time, but that's okay. Left-hand behavior. So if we expand this guy out, the leading term is going to be x to the power of 4. So it should go up to the left and up to the right. Okay. Check. Come on. Okay. The y-intercept, if you set x to 0, everything collapses to 0. So we're going to say the origin here. Okay. The real zeros, okay, so we're fortunate because it's already in factor form. Now I don't want to use the thing, not yet. So we just say it's going to be 0, -2, and it's going to be 6, okay? Multiplicity to 0 on the far left, that's going to be the -2. The power there is a 1, so its multiplicity is 1, okay? The middle 0, which is the origin, has a multiplicity of 2 because of that power of 2. Okay. And then the right one has a multiplicity of 1. Okay. So when x is 4, that's a bit much. 4 times 2 is 8. -2. 256. I think it's a -256. Let me try. I don't know if that's the right number. Let me see. 16. 4 plus 2 is 6. 4 minus 6 is -2. That's 6 times 2 is -12. 16 times -12. 16 times -12. 16. So 2, -32, so -192. 192. Okay, let's go with that one. Okay. So basically, I just plugged in x was 4 and crunched the number. If we expand this, the leading coefficient is positive and the degree of the polynomial is even. So it should go up to the right and up to the left. And there's only one that does that, which is this guy. I basically did the leading term test there. Leading term test, okay? So if you expand this guy out, your leading term is going to be x to the power of 4. So it should go up to the right and up to the left. So it should be A. Okay. So it should go up to the right and up to the left. Our zeros, it should bounce when x is 2. So it can't be A. And it can still be C or D. Our zeros, it should cross when x is 4. And so that means it can't be C. All right, so it has to be D. So basically I was using the zeros with their multiplicities. And I think that brought us to the end. So aside from that one that we got stuck on, again, more than likely it won't pop up on the exam. And even if it did pop up on the exam, it should be within an interactive figure. Really what I've been doing is if an interactive figure pops up on the exam, I just been throwing those questions out. Basically just giving you guys credit for it. Because I mean, that's not testing. Those questions a lot of times aren't testing your content knowledge of mathematics. It's just saying, can you get your machine right? That's something else, right? That's not testing the right stuff. So that's why I've been giving you credit for those questions if they pop up. Okay, did you guys have any questions that you wanted to ask before we go our separate ways? Okay, so if there aren't any burning questions, we're going to end the session here and we'll continue the same time, same place next time. Okay, and from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Peace.